Alrighty, that is us live for our final episode of Ask Databricks. So this is brought to you to give you the chance to ask any questions that you possibly have to the experts from Databricks themselves. So this is your chance. And again, it's our final episode. So it's kind of sad. But again, this is just for season one. We have some kind of season two we're thinking about, we're planning, we're making little plots behind the scenes. So we'll see how that goes. And yeah, so the topic today is medallion architectures. So essentially that idea of bronze, silver, gold, how you're building out your analytical platforms. But essentially, I'm happy that we go wider than that. Anything to do with dimensional modeling in a lake, different ways of modeling your data. You want to talk ETL, how you get data shaped, how you do things like, I don't know, surrogate keys, slightly change dimensions, any of that good stuff you want to ask, then pile your questions into YouTube, LinkedIn, wherever you happen to be watching this. And yeah, we can ask them live with the experts and find out what we should do. So I've got Franco joining me today. I'm going to bring him on. Hey, Franco, welcome to the show.
Hey, thanks for having me.
It is a joy. I've been trying to get you on YouTube for a little while now. So welcome.
Thank you very much.
The way we've been kicking things off is really just to have a bit of a chat about you first. Do you want to tell us how you got into this, your journey, well, how you found like data and data modeling and all that good stuff?
Yeah, happy to. I think a very long time ago now, I was in business. I was practicing as a financial aid advisor and for-profit education, and I noticed that leaders were having problems with data, and I kept hearing them talk about like different problems that we were having. And so I decided to take a lot of these reports, extract them and load them up into Excel, and then learn how to bring them together. And so that was kind of the start of my data journey, was hacking Excel to do different things, and then eventually VBA. And then someone taught me about the SQL thing. And I was like, this is great. So I started learning more about SQL, and that's kind of where my journey started. And then over the years, I learned the Microsoft BI stack, so SQL Server, back then, like reporting services, and eventually Tableau. And I started learning more and more about ETL and data warehousing and business intelligence. And then one day, I was trying to figure out the cloud. This was about 7-8 years ago. And leaders kept asking, what are we going to do with data warehousing in the cloud? And I was like, let's see. Back then, the only non-cloud native data warehouse that existed was our snowy friends. And I decided to kind of take a look at what they had to offer. And it was great. To a data practitioner at the time, you could have decoupled compute and storage. Well, one vendor, you could only use that vendor's compute and storage. But to have that, where at the time we were doing a lot of ELT, where you were using the same warehouse engine to do the transformations. And if you could decouple that to relieve the contention between your BI users and your ELT, that was actually very provocative. And to be able to have like only pay for what you use, like when the compute goes down, you're not paying. These were revolutionary back then. Although
it changed a lot about how we think about this stuff.
Exactly. Although when I went to do one use case, it worked great. The costs were kind of a little bit of a shock with one use case, but we thought it seemed great. We actually, at the time, I worked at a large global commercial real estate firm, and we had big data, and we decided to just experiment. And what we found was a logarithmic growth curve to costs. And so we decided this Snowflake thing doesn't scale. And we had to go back to the drawing board. And I went and I worked on this other project where they were taking sensor data. So at the time, this was 7 years ago, pandemic, no one knew about the pandemic yet. And we were in real estate. And the idea was businesses are not using 100% of their occupancy. So like they're not using all their office space. And the idea was if we could deploy these sensors, do a study and show them how much of their occupancy they're not doing in a streaming dashboard, then we could help them sell like hoteling, remote work packages where they optimize their office space. So the problem was we needed to do streaming BI. And at the time, we had Informatica. Informatica does not do streaming, not very well, not very fast. And so I went to my Azure rep and I was like, hey, what do you have that does streaming? And they're like, there's this new thing called Databricks. And I was like, that's great. What's a Databrick? And he was like, no, not like that. And I was like, okay. So then I basically went to a Code With event where they got one of their Spark experts, and we collaborated for 3 days, and we actually built the whole thing. We were well under budget and finished way before time. And the business leaders were like, how did you do this? What is this magic? And I was like, it's not me. It's this Databricks thing. And then I learned what Delta was. And I'll never forget, I was chatting with some consultant friends of mine who were in data warehousing. And we were discussing, like, what is Delta? Because it was so hard to understand what it was when it first came out. And they were like, well, imagine if you could put a data warehouse, an open data warehouse on a data lake. And it clicked. And I was like, well, everyone is going to want to do that. Why would you want to pay these cloud data warehouse vendors millions and millions of dollars if you could just have an open data warehouse on a data lake, right? So I figured that out. And then Databricks came a knocking, and they were like, would you like to work out of Chicago as an SA on Databricks? And I was like, are you kidding? This is the future, of course. And then the rest is history.
Yeah, it's interesting. There's parallels to my own start on my data journey, except when I started, I was doing a year with IBM, and so I didn't start with Excel. I started with Lotus 123. But the same horrible shift of, here's a spreadsheet of data. Your job for 3 days is to move columns around and then eventually make a report. And it's like, ring the person who made the report going, can you just give me it in the right format? 3 days of work magically go away, and I discovered what ETL was. It started a beautiful journey there via Microsoft Access and some horrendous things back in the day. But yeah, no, it's cool. And yeah, it's introducing people to Delta has always been interesting, right? Because introducing like data warehousing people to Delta, they're like, well, slow clap. You can do all the things a relational database has been not do for years. But then introducing it to lake people who've had the pain of working with a lake for years, they're like, oh my God, this is amazing. This changes our lives. Whereas if you introduce the warehouse people to lakes and the flexibility and the scalability and the throw data in it, and you can separation of storage and compute, they're like, oh, I get it. Why are you trying to sell me on the Delta bits? You should be selling me on the lake bits. And it's the combination of those two that actually then suddenly goes, oh, okay, this makes a lot of sense. Good.
And outbursts Lakehouse, right? And if you think about it, it was at the time, it was a great way. At the time, people thought it was a joke. But unfortunately, it was so difficult to explain how you can fuse the best parts of a data warehouse and a data lake together, that it was just much easier to say, well, Lakehouse, you mean the place where we go fishing? No, and then we have to explain it. So yeah, actually the reason why we started talking about Lakehouse was much easier to explain than trying to start from the primitives of, well, we fuse together, ACID compliance of a data warehouse, all the rules and kind of how you build data warehousing to the lake. And it was like, what a Lakehouse. Oh,
yeah. I mean, that's entirely. All right. So with that context, right? So we've got a Lakehouse. We've taken our warehousing stuff and we said, right, okay, traditional data warehousing, we think there's benefits of separating storage and compute, and the benefits of lake and all that stuff. We've applied Delta or a next generation storage format, so we have scalability, but we have like the protection of a warehouse. Medallion. That's the topic of today. Where does Medallion come from, and how does it fit into that line of thinking?
It's a great question. So if you look at like data warehousing, the standard kind of as it evolved over time was raw staging presentation layer, right? And if you think about that, it's just the same concept. It's just called something different. I would jokingly say it's what we call bronze, silver, gold is what we call raw staging presentation layer in California, because that's kind of where Databricks started. And and there's this old joke. I took it from data scientist is what they call a business analyst in Silicon Valley. So like it's the same concepts. It's just they couldn't, it's on a data lake versus a data warehouse. We had to call it something else. And the Medallion, actually, it came from customers in the very, very, very early days of Delta. It was actually, I forget which customer it was, but somebody actually like came to us and said, well, this is bronze, this is silver, and this is gold. And we were like, oh, that's brilliant. And we just started using it, and it just proliferated like that. But it's like conceptual. It's not super strict. And unfortunately, people get very, very specific with, as you know, over time, we talked about this briefly, like Inman Kimball, you have data, you have all these different things, and there's all these different options, and people get very specific about these things. But you have to realize at the end of the day, it's just conceptual, right? So that's kind of where it started from. And now it's just it's easy to grok, right? It's like, oh, okay, this is where my raw data goes. This data is a little bit more refined, and this data is ready for prime time, right? What's funny is that now we have vendors that are coming up with the diamond layer to represent kind of like a cube or a semantic layer. It's just interesting how now we're adding on top. But yeah, that's where it came from.
I've seen it expanding in both directions. I've heard like tin and like pre-bronze for like, kind of like acquisition layers, plus diamond and platinum and various things. But honestly, I'm not a fan. I am on record of saying I'm not a fan. Partly just because like back in the day, pre Lakehouse days, I worked with lots of data governance teams, and they had this idea of bronze, silver, or gold levels of how trustworthy the data is. And sure, you can take that same concept to the bronze, silver, gold of a Lakehouse, of the Medallion architecture, but it has slightly different meanings, because you could have a business user has prepped their own data and then stood it up. And for the data governance guys, that's silver level data, because it's business user, it's like citizen engineer built. It's not gone through the formal data kind of production standards, but it's curated. It is ready for consumption. So really, there's like a slightly just different horizontal slice. And so I never really adopted the bronze, silver, gold, simply because we were using that terminology for something else that was just slightly conflicting. I mean, but honestly, it doesn't really matter what you call the three. Yeah, you're preparing some data that's like not ready for consumption. You're cleaning up and validating and getting data in a kind of a staging layer, and then you're curating and prepping data for business consumption. And as long as the business understands, when you go, hey, this data's from this area of my lake or my data platform, they go, okay, well, that means I need to think about it in this way. I might need to dedupe it. I'm going to have to figure out some joins. I can just trust that data because someone's gone through the things. As long as they get that context, it's context. It is all just making sure there is context, and then I'm happy.
Exactly.
I do agree with the point of me keeping it different to warehousing, though. Primarily because back in the data warehousing days, when you're doing it on-prem in a SQL Server, your raw layer and your staging layer in your data warehouse were transient, right? You clean it down each time, and then you just have your warehouse, your data mods, whatever is your permanent store. And so calling it something slightly different, just to say, well, actually, it is different because we don't tend to clean these things down. They tend to be materialized long-term mock-ups because lakes are more scalable and cheaper and easier to do that kind of thing. So calling it something slightly different, to say it is slightly different. You need to think about it slightly different. Phases are the same, but the way we do it and how we think about it, how we lay it down is different. Makes sense.
Absolutely.
Okay, so we don't have too many questions. We need more questions coming in. Come on, people. But we've got a couple. One very sarcastic comment saying, "Please bring back data warehouse appliances." No, we like separation of storage compute. We don't have to add a new rack whenever you want to scale. They were the dark times of PDW. Don't like talking about it. It's fine. But yeah, how do you set up delta tables? Is a question. So when you're ahead of the bronze layer, so you're bringing data through, you're kind of pushing things through. Back in the original Lake days, you kind of let whatever's in the data frame, you just materialize the delta table from there. But as delta's evolved, we've got more table properties and identity columns and foreign keys and primary keys, and essentially data modeling has now become more important again. So how do you think about defining delta tables up front versus actually having the properties versus having things dynamic?
So I would say one of the most interesting concepts from data warehousing that has tried to come over to lake housing was, in a data warehouse, you would have to define your schema and then fill it in, right? So you have to know up front, what are all your column types? What are all your table definitions? And it was very, very, we call the schema on write, right? That you define, the schema up front, and you write the schema to the tables, right? And it's very non-flexible. It's very rigid, right? And in a data warehouse, if your data came in and it didn't match the target, your job would fail. And now all of a sudden your DBAs have to figure out like what happened. The vendor decided to add another column, and now the pipeline's broke. So now we have to go back to the raw layer, add some extra logic, and then pipelines can go back on again. So this inflexible nature kind of is not really adaptable to change. And one of the hardest things of data warehousing was, how does it change over time? And I'll never forget when I very early days of my career, I was working in for-profit education, and this was like the era where Obama then came into office, and all these regulations came in, and the business needed data. They needed more data than we ever had before because these regulations were coming down, and we need these extra elements in the data warehouse. And I'll never forget, I got a project request back saying it's going to be 3 months and like $250,000, and someone needs to pay for this. And the business is like, no, you don't understand. We don't have budget, and you just need to give us this data. And I was like, why is it so long and so expensive to update the data warehouse? And I was like, this is ridiculous. I just need to add a couple fields, right? But the entire change management process of a rigid data warehouse does not yield itself flexible enough to the changing dynamics of business. And I noticed this was a big pain all over. Like, as I grew in my career, I switched industries. I've worked in banking, real estate. Like, it's the same thing all over the place. Business changes, data warehouse is rigid. And so it actually, if you ask me, it stems from that you have to define the schema up front. That's kind of where it comes from. And in Lakehouse, one of the very kind of prime concepts is the schema evolution, is that you can define the schema up front. Like, you can totally do create table statements and then do insert into or copy into. You can bring the sins of the past into Lakehouse. We let you do it. So a lot of times when you're migrating, you really like the tools that you've already had, and you're okay if it's not the most efficient way to do it. You're willing to accept a little bit of risk in order to accelerate faster, so you can get, a lot of times it's a very optimal cost to come to Lakehouse. And so you kind of pick and choose what you can boil, because you can't boil the ocean when you migrate, right? So there's been some things that we've been allowing you to do, but one of my very close friends who I've been on a similar journey with, we've both been experimenting with. We were warehouse professionals, and we've been kind of looking at Lakehouse. And with Delta Live tables, you actually don't issue create table statements at all. Actually, in DBT as well, which these are not same things. People get confused about DLT and DBT all the time. They're not competing products at all. They do have similar concepts. And one of them is that you don't define the schema of the table. It's actually interpreted at runtime. You figure out, based upon the select statement, what the table is supposed to be, and then the system creates it on the fly. And then it's very flexible, because if new columns come in, we have something called Schema Evolution or merge schema, where it'll just add the columns to the end. Or there's a lot of different ways where we kind of can rescue the data. If you have really fixed schema, we have this additional column it goes into so it doesn't break pipelines. Or we just add the new data element to the end of the table. And now when things change in the business, it is less difficult to give those new elements to the business so that they can act on it. And this is kind of, how do you set up tables? In Delta, we give you tons of options. Can you define it up front? Absolutely. Can you just do a create table as statement and create the schema on the fly? Absolutely. In Delta Live tables, actually all of how you represent the pipeline is kind of dependent CTASs. So create table as selects all the way down where you're kind of selecting the previous table, and you don't create schema. And one of the comments I heard recently was, I love Delta Live tables because I don't have to think about schema. I have to think about logic and flow and dependencies, which are most important to me and my business. And then kind of DLT just manages that stuff on the back end. But in Delta, you don't have to adopt live tables on Databricks. You can kind of roll your own. But that's kind of what I would say is the first step, is you don't have to think about as much as your schema. So a lot of the prep that was in data warehousing, kind of the way we've solved the problem in Lakehouse is a little bit different, but we still give you the primitives to kind of choose whatever you'd like. Because a lot of times you have the scripts in SQL from your on-prem days, and you just want to slightly refactor those scripts. There's a big concept. There's two big concepts in migrations. There's a lift and shift, which I completely do not agree with. Lift and shift is how you inherit the sins of the past into the future. I really don't think those work. One of our competitors loves lift and shifts, and I have to normally figure out how to fix them constantly after costs just skyrocket out of control. They're like, what do we have to do? And I prefer the concept of minimum viable refactoring. What's the minimum amount we can do? We can refactor in these pipelines to give us the maximum amount of benefit while reducing the amount of friction. And a lot of times that is like picking a couple things that you want to adopt and then kind of putting it on the roadmap to kind of refactor the rest as your resources kind of come together. So what I would say is, like, how do you set it up? It all depends on how you want to get to the Lakehouse. And if you're migrating, that kind of will involve some minimum viable refactoring, where we take some elements from your past scripts and refactor just a minimal amount of things to bring them to the future. But if you're doing that new, I prefer Delta Live tables. I've always thought it's the best way to do ETL, and then we did a benchmark to prove it. And all around, it's actually just like the best way to do ETL in the cloud for as far as costs, reliability, and stability goes. But at the end of the day, if you want to run your create table statements and your insert into statements, because that's what you did, previously, you can do that too. So you don't have to think about it too hard. It's not rigid. We give you options, and then it's kind of figuring out what options that you want to take down to create those pipelines.
I mean, so I'm going to slightly disagree with a part of it. Okay. Certainly for us, the earlier part of your Medallion, your Lakehouse, whatever you're doing, completely agree. Right? The whole idea of having to go and refactor your like early raw bronze tables just so you can first land data is madness. So being held to have like Schema Evolution and just schema defined by the data that's coming in and things evolving, cool. That has saved our lives so many times. Things like the rescue column with autoloader, it's great. We originally did that same level with your gold kind of curated layer of saying, yeah, I mean, we'll have some business logic, store it as views, store it as DLT, SQL tables, whatever you happen to do. And then that will implicitly create whatever kind of data model that's defined by the logic. For us, as Delta's come out with more and more things that are set on the table properties that are essentially defined in your create table statements, or as you do constraints and identity columns, or you're trying to do surrogate keys, you're trying to use some of the newer Delta features to say, this is actually part of my data model. We kind of switch back to doing it the way that we used to do in terms of just your gold layer, your deliberately designed data model that you're fitting the incoming data streams into. We kind of do structure that. We create those tables and say, this is the deliberately designed data product I'm trying to map my data to. Part of that is because of how you go about designing these things. So with traditional lakehouses, it's you have a load of data streams coming in, and you're just handling that. You're handling all that data. You're managing to land it. You're managing to clean it. But then, I mean, historically, loads of people design their data models based on what data they have. They get shown a load of data from a system, and they go, right, what can I make out of this? Cool. There you go, business users. There's a data model I've made for you. And the business users go, I don't know what that is. Well, what are these things? What are those system names? I don't understand it. So we do it the other way around. If you go to the business, you run a load of data modeling workshops. The business designs a data model. Then you go, cool, that's my end state. How do I get from my data into there? But to have that end state designed, again, it's the way we do it is that's then a data model. And you could even do mad things in a Lakehouse, like, have some kind of data model diagram. And I know that's old school. But again, there's different approaches depending on how you're trying to build it, depending on your use case. Are you building a star schema, or are you going Vault? Are you going something else? Are you doing one big table to go and just throw into things like Tableau? It depends, obviously. And I guess that's the answer to that question of depends what you're trying to do, depends which features you're trying to mix together as to what actually makes sense. But yeah, I've got loads of other questions coming in now. So we'll plow through a couple of the questions that we've got in there. One is a slightly spicy one if you're an old school SQL person. And I promise this is an actual question, not just throwing this at you. Does Kimball or Inman work best for a Lakehouse?
Ooh. So this is good. I like this. I actually have my theories, and I actually went to one of our lead engineers and I asked the same question. I was like, okay, knowing what you know about everything, which one is better? Is it Inman, Kimball, or Data Vault? And we've gone back and forth on this topic a bunch of times. With all of the things that have gone into Spark. So Spark 2 was a really pivotal moment in the transition to actually having Lakehouse, because a lot of capabilities that went in there were for dimensional modeling, for typical star schema. Before that, typical Spark table, like before, yeah, and that was slightly before Delta too, because we started introducing Delta around 2.0. One big table was kind of how people did things, because usually everyone used it for machine learning, because that's it was data lake based, and feature tables are one big table, right? So that's kind of how everything was designed. So, but Spark 2 and beyond into Spark 3, a lot of these, what you need to have optimal data models for star schema or snowflake schema, and Data Vault a little bit. I'll talk about Data Vault's actually special, and I want to talk more about that in a second. But let's just stick to what is better. I don't really think there's a winner when you're talking about Kimball and Inman. The things that we've put into Spark and Delta, primarily it's dynamic file pruning. Essentially, when you have a dim that filters a fact is the primary thing that how you get performance. That was implemented a while ago in the stack. And so, whether it doesn't really matter anymore, you're going to get very similar on the read side, right? Now, what's very interesting is if you ask me which is more performant on the ETL side. So Inman and Kimball, actually a part of dimensional modeling, the core of it, if you want to do it right, is SCD type 2, or slowly changing dimensions. And this requires a merge, because you have to expire a current record, insert a new record, right? So it requires, the core of it requires a change, right, to the records. Object store is immutable. Delta, basically the core of the Delta protocol is when there's an update, delete, or that not anything but a non-insert, right? We actually, we used to write out a new file with the change records. Now we have deletion vectors. It's a little bit different. But essentially, on object store, to change a record, it involves a lot more work than just inserting a record. You can insert a record super easy. Think about Data Vault. Data Vault is insert only primarily. There's very, very few use cases where you want to update a current record, because Data Vault, one of the core pieces to it is adapting to change over time. And really, updates are not great for a flexibility of change over time. And so the insert only architecture, I believe, is more efficient on ETL. And then on the read side, we don't find a major difference because of all of the techniques that have been implemented on Spark and Delta and with Photon now. The read side, it's going to be all similar. I don't really think that there is a lot more we can do on the read side. But on the ETL side, what I want to do is we did a benchmark, which funnily enough is a Kimball-based dimensional data warehouse. Actually, no, I'm sorry. It's an Inman-based data warehouse, but it's got a dimensional data model, which you build from flat files. I actually want to change this benchmark to be Data Vault, because I want to bake off, like, which is more, because it's an ETL benchmark, which is more efficient on object store. So I don't know yet, but my hunch is if you're looking for like the end-to-end, like which is the winner, I think Data Vault has a leg up primarily because it's insert only, and object store itself is immutable. I think that, so personally, this is a personal thing. Engineering at Databricks is kind of, they haven't picked a winner if you're asking like core, but my hunch is that Data Vault actually has a leg up because of its core insert only architecture. If that helps people make. Now, I'm not saying I don't want people to think now we have to go and redo all of our pipelines to Data Vault. No. My advice to usually every customer is use what your data workers are most comfortable with, because the change in your ops and like just cost ops is immaterial to the amount of change management to change your entire core data model. It's immaterial, right? If you want to, over time, evolve and slowly minimum viable refactoring, get to it, that's one thing. But I don't think you should come to you shouldn't do a lot of change at once. If you come to Lakehouse, come as you are, and then over time you can optimize and adapt. But that's kind of how I see pick a winner. There's not a clear winner, I don't think. We don't see one at Databricks, but I think Data Vault has a leg up if on the ingestion side, on the transformation side.
Cool. I mean, I'm going to stay quiet. I think people know fair well my opinions on Data Vault, and I'm just going to quietly skirt around that one.
I want to tell you that I agree with you. I think it's overly complicated. I think it's very, very heavy on change management, because it's a big change to how you model and do everything. And I agree with some of the things, but to me, I like being healthily curious, and I like to make sure I don't just discount things because I don't like them and I think they're very hard, right?
So for me, the main argument has been scale, and it's the scale of change you're trying to deal with. And I think a lot of people we speak to, they're dealing with small amounts of change, and like the protecting themselves against change by introducing the process isn't really worth the trade-off of the complexity that's introduced. If you're dealing with a bank and they have hundreds of thousands of source systems that need this incredibly complex change management process, it's a great architecture for dealing with it. It's one of those ones where it's if that's your hammer, then literally every data problem becomes a nail. And that's the kind of thing that's rife in the data industry, that, we're specialists in a certain area, therefore everything looks like a solution with that problem. And that's what I've generally found with Data Vault. But then I'm guilty of that as a Kimball guy, in that everything's a star schema at the end of the day. It's just the way it is.
Star schema is super simple. If you have very simple data and you just have very simple business requirements, if the way I kind of think about it is, if you're a wholly owned company with one set of source systems, you can't beat star schema, right? It's super simple to implement. But again, you hit the nail on the head, pun intended, that if you're a large organization, and typically if you've grown through acquisition and your source systems, you have the same type of system, but different systems for the same things for your business lines. And now you need to conform data from multiple source systems into the same data model. I think Data Vault kind of wins that. But then, like you said, it all depends. I think you really have to think about, the complete solution of what you're trying to deliver. There's not one clean answer.
Yeah. Okay. We're out of time, and we haven't gone through that many questions. So I'm going to do some short, sharp, like implementation questions. So if you've got nested data types, where in your medallion do you think about unpacking?
Oh, okay. So
I didn't say it was easy questions.
Yeah, no, this is good. All right. So nested data is interesting. Depending upon what solution that you implement, people do this differently. Some people don't unnest them, and they get all the way to gold with just the nested structures. Because in Databricks, we have structs and arrays. In Parquet Delta, like, it has ways to handle the different types of nested structures. But when you ingest JSON or XML, still a fair bit of the world that processes XML, you have that nested data. How do you denest it? And so what I commonly see, I'll say the naive approach, is I'm just from bronze to silver, I'm going to unnest all the data. And essentially, I call it Cartesian e-product. of it, where you're duplicating a lot of the data, you're unpivoting, if you want to think of it that way,
Mm-hmm.
all of the nested structures into their own columns. Now you have an explosion of rows because every nest, now you're unpivoting it into itself. And then I get customers who do that coming back and complaining about storage costs. And it's like, well, you duplicated, it's not duplicated, but it's you kind of exponentially created extra copies of data because you just unnested everything at that level. And then the other approach I actually think is better. If you think about nesting as a join to another table, right? Like it's an inner join to another table. You can unnest nested objects into their own table object. If you have gnarly nested structures, I think it's the more official approach. It's the more adaptable approach. It's more difficult to implement. But silver is where I see a lot of the unnesting. Or if you're not unnesting, if you're not kind of fanning that data out, I do see organizations just actually in gold, they have structs and arrays, and then you would in the different layers of gold. You talked about this previously. Bronze, silver, gold is not super strict. It's conceptual, right? You could have types of gold, right? I've actually seen where you in gold have those nested structures, because a lot of times data scientists will want that for when they're doing feature engineering processing.
Yeah, absolutely.
And then data analysts don't typically want that. They'll want like the dimensional model tables. But you would then create views or something on top of so you'd have a more derived gold that fans out the data for analysts. So I've seen both implementations, but typically silver is where I'll see people unnest it. So you could have that row level detail.
I mean, like, certainly if you have the kind of thing where you get like one single JSON file that's just one massive object, and all of your actual transaction records are just inside a nested array. Generally, for sheer scalability for Spark, so it can distribute those records over multiple workers, it's better to unpack that, depending on the data type, depending on your scenarios, depending on what you need to do, depending on what kind of nesting we're talking about. So yeah, commonly we'll just append that into raw and then pull it out into separate silver tables where we're talking about, kind of doing that unpacking if it's that kind of heavily packed thing. Which absolutely, if it's just a struct of various attributes and it doesn't need to be, you don't need to flatten it out. Unless you need to have statistics correct on it for delta, and it's a performance thing, it gets into performance tuning, and loads. And again, short, sharp, complex question. We got more. Interesting one. Business users distrust the silver tables that the engineers are making, so they'd rather make their own silver tables. So you end up with multiple versions of the truth. How do you handle that? How do you go about navigating that business problem?
Okay, actually. This is where I'm going to talk about where I see people use DLT and DBT, because this is the best way that I can conceptualize the ultimate solution to this problem. And you kind of touched on this earlier when you said that if you, as data professional, if you start with the data, profile the data, build your own data model, give it to the business is like, what the heck is this? Right? Because the people in IT created it, and I don't know what these columns are. But if you take it the other way around, and you start with the business and you say, what data do you need? Build the data model, and then go backwards. Now you just translate, this is what ETL is. You map the conceptual data model to the physical data model, and boom, now you have a data warehouse. What I think is what I've seen is the most successful implementation of Lakehouse at these modern organizations. And I don't know if we have a funny name for it. It's not data mesh. Before data mesh, we called it self-service. But basically, it's this concept of you as the core data team, I need you to ingest and land the data in a place where my business analytics engineers can take that data and build us our own derived objects so that we can use them for reporting, dashboards, and all of our needs. So where I see the most successful organizations is actually using DLT for core ingestion. So IT really likes Delta Live tables because it's a real simple, scalable way, includes streaming. It checks all the boxes. But the data teams or the analytics engineers love DBT. And this is where I see DLT being used for core ingestion and kind of what people commonly call bronze to silver. And then I see DBT coming in and doing silver to gold. And this is where you empower the analytics engineers with their tooling. And they commonly use Databricks SQL. And they can even use streaming tables and materialized views from within DBT. So you can continue on the stream incremental processing. And I see this as the emerging pattern, whether we can create a funny name, maybe a medallion mesh, if you want to call it that.
Medallion.
Medallion. This is great. We're coming up with new fun names.
Please don't turn that into a thing. I don't want to see that as a T-shirt next time I see you.
Hashtag Medallion. I do like to make T-shirts. So that's kind of what I'm seeing as the emerging pattern. And really, if you think about, what the heart of self-service or mesh is empowering the business technical folks, right? The analytics engineers, or business intelligence analysts, as we used to call them in my day. These people that knew the business, they were in the business every day. They understood their problems. They spoke their language, if you will, but they also spoke the technical language of SQL, and they could dive into the tables and figure out what the business needed. I see that as the emerging pattern out there, and I think that is what really solves this kind of how does core data and the business analytics teams work together. That's kind of what I see as people leveraging it.
And I agree entirely. It's a communication issue, really. And whilst Mesh has brought lots of vendors cynically trying to sell it as the answer to everything, because that's what consultancies do, it's brought, like, the one thing it's brought to the forefront, which is great, is the idea of treating data as a product once again. And it's confusingly called either data as a product or data products, or call it what you will. But the problem with those silver tables, how do you get the business users to trust the silver tables and actually use the silver tables? Talk to them and actually treat it like a feature backlog, and have them take ownership and prioritizing which of the features to put in, how get them to define the cleaning rules that are applied to the silver tables, even if it's centrally managed by a team who's just shoveling data and making a silver table so that federated analytics can pick it up and build their data models off it. But if they want to be able to trust the same silver table, they need to be part of that process of the production of that silver table, even if it's just giving the requirements and saying, cool, I'm the product owner for this set of silver tables, give me some requirements and I'll actually enact it. But people don't do that. It's like engineers go, right, there's a table, I'm going to slap it into silver, I'm going to take a look at it, I'm going to decide what cleaning it needs. They don't speak to the business about what cleaning needs to be applied. And then you get that disjointed perception of, but that's not a silver table for me, so I'll make my own. And then you have proliferation of many copies of the truth. It doesn't work.
Completely agree.
We have the same problems over and over again. It's the data industry. It's what we do.
Really, what I like to call this is I'm a data therapist. I come into organizations, and a lot of times I either get brought in by business or core data team. And really, I come in, it's like, okay, well, let's talk to each other. What problems are we having? And it's really, I'm just bridging these two organizations together, and I'm listening, being a therapist. Where's the pain? And I'm helping bridge these two organizations together with some tech.
Pretty much. It's what we do. We help people with their problems.
Yeah.
Other quick ones. Surrogate keys. How do you think about surrogate keys in the new world? What's that come in? How important are they?
This is interesting. Actually, I don't know if a lot of people know. At Databricks, so I've been around for a while, going on 5 years now. And we didn't have a data warehousing product when I started Databricks, right? And there were no such thing as identity columns or surrogate keys in Spark Delta land back then. And I, over my course here, Databricks does ETL amazingly well. Like, it's actually our superpower. Spark and Delta are like the dream team for processing data, and ETL is just processing data, right? And we've never, ever benchmarked ETL. Obviously, everyone's heard about TP-CDS, which is query serving. That's half of the data warehouse equation. ETL is actually, it's probably the most expensive part, but nobody really does anything there. And so I wanted to do an ETL benchmark at Databricks. We worked on it for longer than I'd like to say, because there was one big thing that was missing that you need for a dimensional data warehouse. You need surrogate keys. You need to be able to generate an identity column. And this was actually one feature that I was bird dogging or hounding product and engineering for, because in order to complete this benchmark, I needed identity columns. And the other way to do it, it was very bad. There are a plethora of ways that very crafty engineers have created over the time to actually try to get this in there. And people think, why is it so hard to create a sequential key? Well, the core of distributed compute is that you can't sync a key across a group of computers without, you have the speed of light problem with networking. So actually, surrogate keys, I think, have a very, very good place in the Lakehouse. I would champion this. If you go look at the blog for identity columns or surrogate keys in Databricks, I was the author, because we needed that in order to compete with data warehousing. So I think they have a front and center place. And now, instead of Databricks Unity Catalog, you have primary key and foreign keys. If you define them, they show up. And then if you're using a BI report, some BI tools have the ability to kind of display the data model. So I think they have a front and center approach. And I internally at Databricks, I championed their way to production and GA back when we didn't have them. So that's how I feel about surrogate keys. I think they're very important. And the reason why is for that performance feature I talked about a while ago, dynamic file pruning. In order to figure out how to filter facts, right, with DIMs, you have to be able to have that key to filter out those objects. So that's how I feel about it.
Yeah, I mean, depending on which like semantic model, which BI tool you're putting it into, it has varying levels of importance. If you're going for like one giant big table, you don't end up needing things like surrogate keys. But if you're putting it into something like Power BI like much prefers if you've got int-based keys that it's joining to. And if you need int-based keys, suddenly that is a data modeling problem that you need to implement something that's actually doing surrogates for you, rather than like hashed keys and various things that people have been doing in lakes for years. Suddenly you have to go, oh, that doesn't work anymore, because my data consumer, the person using my data, that's not ideal for them. Therefore, us as engineers, we take the pain and we have to figure out a better way of doing it. And yeah, identity columns is a great way of fixing it. I really appreciate we're getting near time. So I've got like a very wide question for you. So there's a few different questions about kind of how we measure things in bronze and how we look after data quality in silver. What's the bare minimum you should do as a medallion? There's like a bunch of questions like that. So do you want to give us a quick rundown of data coming in, maybe kind of someone sending us some files? How do you think of it moving through that architecture? How do you look after data quality? And how should someone think about producing data using this approach?
Yeah.
Wide question.
Yeah, I would say a lot of these problems are end-to-end problems, right? And how we think about them at Databricks is typically organizations. If you think about Lakehouse, what is it? It's actually the unification of a lot of these problems that independent vendors have solved over time. But at Databricks, we think that you should unify everything that you can into one platform, because then things get much simpler. So we think a lot of these problems end to end, instead of a lot of people think of them in silos of, I need to ingest my data, I need to transform my data, and I need to do data quality. And so typically they'll buy these tools that handle these things, but these tools don't communicate with each other. They don't understand that down the line, I'm only needing this one data element, and up the line, I can actually save a lot of money if I change the processing. And a lot of these problems we solve with Delta Live tables. Is how can you handle ingestion, transformation, optimization, data quality, and the kind of all the things that you need to account for across the pipeline, right? And so built inside of Delta Live tables is expectations, where you can put a kind of expression to expect certain things, right? And then in Unity Catalog and in Databricks SQL, then you can actually see the results of the data quality. So you could build dashboards in Databricks SQL to see the data quality over time. And you have Unity kind of providing all that governance. It's this really great solution where you've had to really pick, I have to have a catalog of catalogs, because usually the warehouse just catalogs the warehouse. And then I'm going to need a catalog of catalogs. I'm going to need an ingestion tool. I'm going to need a transformation tool. And then I'm going to need a data quality tool. And really what I sum this all up is like, do you really want to like pick best of breed tools and trying to stitch together all these loosely coupled cloud components or all these independent SaaS vendors and hope that their roadmaps are aligned so you can integrate them? Or do you want a complete solution end to end that really understands all of the problems you're trying to solve across the line to get from how you get data all the way to how it's being used in the business? And one of the core things I think is super important to all of this, to the communication problem that you were alluding to earlier, the communication problem between the business and core IT is lineage. And not lineage as an afterthought, because I've experienced this where you have to define lineage after the fact. What happens? As soon as it's defined, it's out of date, right? How fast do things change in the business? Within the stack of Databricks, within Unity Catalog, we automatically capture lineage, no matter what compute you're using. So I'll give a great example. I said earlier, core IT likes to use Delta Live tables. Analytics engineers prefer DBT. Well, with Unity Catalog, we automatically capture the lineage and logic of everything. So essentially, if a business partner has a problem, how did this data get in this report? You can then, inside of Unity Catalog, track exactly back to where that came from and all of the logic that it went through, column level, to the destination. So when I think of like all of these problems that organizations have along the stack, and it's because they've been trying to stitch together these best of breed tools together, because they have all these things that the business needs. The business needs quality data. The business needs lineage. The business needs to know what data is the most used. And one of the concepts that I thought is amusing that came out from kind of implementing these things at scale is all of a sudden we found that there are these things called zombie tables, where expensive pipelines are filling them up, but no one from the business is using them. So it's like, why are we paying to fill these zombie tables that no one's using? And now, because you have an end-to-end platform that knows lineage, you can see exactly where that source is coming from, what pipeline is producing it, and you can say, maybe it doesn't need to be every hour. Maybe this one's going to be a daily load because it's not really used a whole lot, right? So that's kind of how I think about it. Databricks has been focusing on how do we solve these problems that these organizations are having very simply in an end-to-end fashion, right? We like thinking from first principles and then, trying to be as simple and elegant as possible to the end user. And so that's kind of how I think about all of these problems that organizations have had about trying to point solution across the stack.
So I've got that's probably a final question, given time. I've a data modeling or an analytics philosophy question for you. So I tend to find most people, and this is purely a question for me, tend to find most people fall into one or two camps. Either, say you're making a star schema, you're making some kind of data model, and you're providing a dashboard back to the business. If the data quality coming from the source system is rubbish, then the dashboard shows rubbish. Garbage in, garbage out. If the source is rubbish, your responsibility as an analytics person is to show them it's rubbish, to create impetus to go and actually fix the source system, and then maybe the circle of life continues. Or your responsibility as the analytics person is the guardian of that, and you should only show the business data that is actually cleaned and solid and right, and you are the bulkhead that stops data quality, dirty data reaching the business. And honestly, neither of them is right, because it very much depends on the data culture. But where do you sit personally?
What are the choices? I'm sorry. What were the choices again?
So as an analytics person, is it your responsibility to show the absolute truth of the data regardless of how bad it is? Or is it to tidy it up and clean it out and show a sanitized view of the world to the business, which might hide away problems in the source system?
So again, this is a communication problem. As an engineer, how do you know what's clean and what makes sense to the business? And I think that this problem is like the core of what I think Hadoop got wrong. Was core IT was like, we're going to do schema on read. It's fine. The business will figure out what they want. We don't know what they want, because they found that every time they tried delivering a solution, the business wanted something else. Oh, we'll do schema on read and we'll have them figure it out. They're not going to want to figure it all out from raw data, right? And then you had kind of warehousing with schema on write. And this is what I think the unification of Lakehouse is that you have to actually do both. This is the core of bronze, silver, gold, is I do schema on read, and then I do schema on write. We actually do them both, right? So I think that this is why also I think the DLT plus DBT architecture pattern, or medallion mesh, or meshdallion, is the way, because
created a monster.
we have right here in this show, because I don't think the business doesn't know how to kind of do core ingestion, and IT or data doesn't know all of the logic and all of the ways that the data represents itself to the business, like how they actually interpret and use it and how things change over time. So I think that it's not a one-size-fits-all solution. So that's kind of where I land on there. Does that help?
Yeah, no, it's just an interesting thing because we tend to find, obviously, it depends on the business, depends what they're trying to do. If you're a regulated industry, you cannot show data that is not right. Therefore, you have to stop data being produced. You have to not refresh your reporting model that day because the data dropped below a certain quality. But then we have so many problems with ownership that actually we tend to find if you show people how bad the data is, and you like they get a report and it's meaningless because they've put so much junk in their source system, that then gives them a kick to go and actually fix it. And there's just this endless like choice of going, do you show people the actual truth, or do you like refuse to show them, but then they don't actually fix it because they don't realize how bad it is? And until we actually get businesses taking actual ownership for their data, and the idea of data products go off, and you have data product owners for everything.
Or
we need to decide.
if they ask you, can you just fix this in my report? I think the one evil thing that I've been asked over my entire career is I know the data's wrong. And I'd say, okay, go back to the source system and fix it. We can't do that. Can you just fix it in the report? And it's like, no. We should really fix. And I'll never forget. I was literally asked from the top down, do it. Just fix it in the report. And it's like, you don't understand. This is why when someone looks at a report and they go back to the source that it doesn't match, like this is where it comes from. I kind of, it's interesting how we have to deal with these problems as IT professionals, as data professionals, and the business.
And I'm curious how many people at home are thinking of how many case statements they have in some of their gnarly ETL logic specifically to deal with that given problem. And there's so many out there. We see so many of them. But I'm very aware of time. That brings us to the end of our last and final show of this first season. Any parting words of wisdom or Medallion you want to share with people at home?
Yes. So a lot of times, folks need reference in order to understand this, right? The data quality, how does it work, bronze, silver, gold? Earlier this year, we published the ETL benchmark that I've been working on for quite a while. It's called TPCDI. If you Google search 1 billion rows for less than $1, should be the first hit that comes up. That was our blog. That was marketing. We really we wanted something like 1,000 songs in your pocket to really like kind of have the market react. Yeah. But what I like to tell folks is that we took a terabyte of flat files with all of the complex business logic of building a dim and fact data warehouse, including bad data that has to be cleaned up, SCD type 2, window functions, complex business logic, and build dim and fact tables. So we actually wrote all the code. We wrote how to do this in regular workflows, manually doing everything in Delta Live tables, and we implemented it with DBT as well. And we kind of have a repo done by my great friend Shannon Barrow, and Roberto Salcido kind of helped out with the DBT side. And essentially, we made all this public, so you can actually see how do I do bronze, silver, gold? I need reference. Some people need to see it. So if you look up that blog, there's a repo that's in it that we open sourced all the code on how to do this. You have reference material on how to do bronze, silver, gold with dirty data. So if you need to understand how to do data quality with this reference implementation. So if you absolutely need to see it, right? You need to see it to understand it. Check that out. 1 billion rows for less than $1. That was kind of something that I've been working on for a while at Databricks.
Amazing. I mean, if you ping us a link, we're going to drop some links in each of the chats as we come to the end of things. So we'll include that link so people can just go straight to it rather than try and Google around for it. But yeah, no. Franco, thanks for coming on the show. Thank you for sharing your Medallion wisdom. And I'll close out. So thank you.
Thank you.
All right, so that is the end of our final show of the first season of Ask Databricks. Again, if you guys enjoyed this, if it's valuable, if it's useful, then please do let us know. And we are very happy to line up a round 2 and figure out kind of the topic and figure out the people. And if there's certain people you want to hear from, then absolutely do let us know. We know there's a ton of extra questions around Medallion architecture. We'll see what we can do to collect them all up and, kind of just publish a little bit more follow-up about, hey, here's all the things we didn't get to. So do hold out for that. And yeah, we're going to share a little bit more information around, again, so some links, how you can find out that huge case study of that amount of data to be that cheap. And yeah, otherwise, thank you so much for tuning in. This is a recorded session, so you will be able to go back and watch it. So just asked in the chat. There you go, a little final question sneaked in. And yeah, catch you next time. Cheers.